Welcome in Tilco Advisors. We empower construction material manufacturers with cutting-edge digital solutions. And now, welcome to our podcast, where we share insights from the world of smart construction technologies.
You're here for the shortcut, and today we are cutting straight to the chase.
We are.
We're looking at how digital twins and artificial intelligence are delivering real, tangible value.
Right now.
Exactly. Not in 5 years, but for construction companies planning for 2026. Our mission is to show you what this tech looks like when it's actually working on a messy, real-world site.
And that framing is so important. I mean, for years, AI in the built environment felt a bit like science fiction.
Something way off in the future.
Yeah, too complex, too expensive for daily use. But it's really moving into the practical operational space now.
So it's finally here.
It is. And when you fuse that AI intelligence with a digital twin, you fundamentally change the game. You get more efficiency, more resilience, and you drive innovation. We're here to give you the clear bottom line benefits.
Okay, so let's unpack the core tech first, because we hear digital twin or DT, and I think a lot of people just picture a static, super high-res 3D model.
That's the first thing to clear up. It is so much more than that.
It's a dynamic relationship, right?
Right.
Based on 3 key parts.
Exactly. A digital twin isn't a picture. It's a living thing.
Okay.
So you have the physical object itself, the building, the excavator, the bridge.
The real thing.
The real thing. Then you have its digital representation. But the critical piece, the real magic, is the third one.
The data connection.
The real-time data flow. The information links that constantly connect the physical and the digital. So you should think of it less like a mirror and more like a building with a real-time nervous system.
I like that. A nervous system constantly sending feedback.
Constantly. On everything.
Which, of course, brings up BIM building information modeling. I mean, that's been handling the detailed modeling side for a long time.
It has, and BIM is the absolute foundation. You need that detailed blueprint.
So where does the digital twin take that BIM model and, accelerate its value?
The DT unlocks its full potential. It fuses that incredibly detailed model with live data from IoT sensors, with cloud analytics, and most importantly, with AI.
So it's taking the static plan and making it dynamic.
Precisely. While BIM is mostly focused on planning and design, the DT lets you monitor the live asset and make informed decisions across the entire life cycle. It keeps the model true from the moment the doors open.
Okay, so let's jump right in. Where is this creating tangible value today? If we look at the whole project lifespan, where are we seeing DT used most effectively?
Well, based on all the current research and what's being implemented, the applications are most developed, most tangible in 2 key phases.
Which are?
The really intense construction phase and then the long-term operation and maintenance phase.
Interesting. So not so much in the early planning or the final demolition.
Much less prevalent there, at least for now. The focus is definitely on the build and operate stages.
Okay, so let's zero in on the build. Project management on a construction site. It's chaotic. You've got fractured teams, architects, engineers, contractors, clients.
All with their own set of documents.
Right. How does a DT fix that communication mess?
It creates a single source of truth, synchronized, in real time.
So no more arguing over which set of blueprints is the right one.
Exactly. Instead of people relying on static documents that are instantly outdated, everyone sees the same current status live.
Which must cut down on rework.
It drastically reduces confusion and minimizes that incredibly expensive rework. And it makes decisions faster when, something unexpected happens on site.
And the data it captures, it's not just showing progress, is it? It's becoming this archive of knowledge that can inform future decisions.
Yes, that's a key point. You're moving beyond just optimizing the build cost.
You're thinking long term.
You are. The DT lets you simulate and forecast the effects of different construction techniques on, say, energy use or structural integrity before you even commit.
So you can model things like which supplier to use or which material will have lower maintenance costs down the line.
Precisely. Should you use supplier A or supplier B? What's the cost profile for material X versus Y over 30 years? The DT's database gives you the data to back up those huge financial decisions.
And that value just carries straight over into the operations phase, which is great because facility maintenance has kind of always been a bit behind on digitalization compared to design work.
It's a persistent gap, absolutely. DT tackles it head-on by collecting live performance data once the building is actually in use.
So you're shifting from reactive to proactive.
You've got it. It fundamentally changes the job for facility managers. They're not just fixing things when they break anymore. They're enhancing their decision-making based on the asset's real-time needs. Maintenance becomes predictable, not a costly surprise.
Which is the perfect pivot to AI.
Right.
Because AI is the layer that takes all that real-time data from the digital twin and makes it, well, predictive. Let's start with what the sources say is the highest impact application. Predictive maintenance, PDM.
PDM is the intelligence engine. It uses AI, machine learning, and that whole network of IoT sensors in the DT to anticipate when equipment will fail.
So we're not just talking about routine scheduled maintenance here.
Yeah. No, this is way beyond that. We're talking about predicting that a specific bearing in a specific HVAC pump is going to fail in the next 2 weeks.
How?
Based on tiny changes in temperature, vibration, maybe even sound patterns that a human would never notice.
And for a construction company that relies on incredibly expensive, heavy machinery, the value there must be enormous. What are the hard numbers?
The benefits are substantial. We're seeing maintenance costs drop by 25 to 30%.
That's huge.
But here's the crucial one: unplanned downtime. That's the biggest killer of project schedules. That can decrease by up to 70%.
70%.
Up to 70. And when you get into the weeds, AI-driven maintenance cuts that downtime by as much as 50% and can extend the life of the asset by 20%. The algorithms are getting incredibly good, up to 90% accuracy in detecting anomalies.
Those numbers sound amazing, but they often come from very controlled environments, right? Like a clean manufacturing plant. How realistic is it to take that success and apply it to a muddy, chaotic construction site?
That is a critical question. And we have to look at how leading companies are already doing it. Take Rolls-Royce, for instance.
In aerospace.
Right. They use machine learning to analyze jet engine telemetry while it's in the air. They've cut unscheduled maintenance by 40%.
Okay, so what's the construction equivalent?
The heavy machinery fleet. Look at Caterpillar's Cat Connect system. It uses AI to process all the telematics data from their equipment on site.
And the results?
They're reporting reductions in unplanned downtime by 20% and extending the equipment lifespan by 15%.
So it does translate.
It does. The site is messier, sure, but the principle is identical. The DT provides the structured data, and the AI finds the patterns of failure before they happen. It takes the guesswork out of it.
And that fleet data ties right into the next big application. AI fleet performance optimization. So it's not just about when a bulldozer needs an oil change.
Not at all. It's about how that whole fleet moves and operates. The DT now has not just the machine's health data, but its operational data too.
Like fuel use, idle time.
Fuel use, idle time, load cycles, GPS location, everything. AI monitors all of it to optimize routes, deployment schedules, even maintenance windows.
So you're making sure every asset is being used as efficiently as possible.
Exactly. And we can look at global transportation market data here. These systems can improve overall fleet efficiency by up to 15% and cut operational costs by as much as 20%.
That's optimizing the assets. Let's shift now to optimizing the site itself. We're moving from machine sensors to visual data. The next big trend is computer vision, basically giving the digital twin eyes.
Computer vision, or CV, is set for massive growth. The market is expected to hit, something like $63 billion globally by 2030?
And what is it, fundamentally?
It's teaching computers to interpret the visual world. Images, video. It uses deep learning techniques, things like convolutional neural networks, which are just specialized algorithms really good at recognizing patterns and objects in a picture.
So how does that pattern recognition turn into value on a construction site?
It means you get real-time site monitoring, automated quality inspections, and critical spatial analytics. But where it really shines is safety.
Safety.
Our sources give CV a strategic impact score of 8.3 out of 10 for safety.
And why so high?
Because real-time risk detection accelerates incident prevention. The AI can watch every worker, check for PPE compliance in hazard zones, identify objects where they shouldn't be.
It's a constant, unbiased observer.
Far more effective than any human can be over a long shift.
And to make this real, the sources pointed to a fantastic infrastructure example.
Right. The idea being, if CV can handle dynamic city traffic, it can definitely manage construction logistics.
You're talking about Dubai.
Exactly. In Dubai, the smart traffic signals use AI and CV, pulling data from over 1,000 smart cameras.
What do they do with all that video?
The AI continuously analyzes vehicle and pedestrian flow and dynamically adjusts the signal timings. The result they recorded was a 25% reduction in congestion during peak hours.
Wow. So it takes that real-world visual chaos and turns it into real-time operational optimization.
That's the power of it.
And this visual intelligence connects directly to the, I guess, the execution layer, on-site automation, construction robotics.
This is where you see the final physical result of all that AI intelligence. Robotics integrates the AI and a ton of sensors to automate tasks that are precise, repetitive, or just plain hazardous.
Which is why it scores highest on safety.
Highest of all, 8.9 out of 10. This is the new frontier, and you're seeing it pioneered on mega projects.
Like the NEOM project in Saudi Arabia. They have a staggering metric on this.
They do. NEOM's joint venture with Samsung C&T is automating the assembly of rebar cages using robotic welding.
And the projection.
It's revolutionary. They expect to reduce the manual labor hours for just that one task by up to 80% and lower the assembly costs by 40%.
80%, that's not an incremental improvement.
It's a massive operational leap. It shifts labor from purely manual work to more supervisory roles.
And we're not just talking about fixed robots in one spot, are we? We're also seeing mobile autonomous systems navigating the site.
That's where it gets really interesting. You have quadrupedal robots. Think of systems like Boston Dynamics Spot being deployed.
And how do they navigate?
They use LiDAR and advanced algorithms called SLAM, which stands for Simultaneous Localization and Mapping.
Okay, can you simplify SLAM for us?
Sure. It's basically the tech that lets a robot build a detailed 3D map of a place it's never been before, while also knowing its exact location within that map it's building.
So they're autonomously mapping and monitoring the site, even over rough ground.
Correct. They improve oversight and efficiency, collecting super accurate data at speeds of up to 3.5 miles per hour. And they take humans out of dangerous inspection jobs, like checking high scaffolding or unstable trenches.
We've painted a picture of incredible efficiency, cost savings, major safety transformation. But the promise of a deep dive is to give thorough knowledge. So we have to talk about the obstacles. What are the big roadblocks companies need to plan for to actually realize these benefits by 2026?
And that's critical, because these challenges define the true cost and complexity of adopting all this. We can really group them into 3 main areas.
Let's start with the financial and technical hurdles. That integration piece sounds particularly tough.
It is. The first barrier is cost and integration. These robotic solutions, they require huge upfront capital expenditures. The sources give them a pretty low cost score, 5.6 out of 10, because that ROI period can be quite long.
And it's not just the sticker price of the tech.
Not even close. The bigger problem is technical integration. Construction sites have a dizzying array of hardware and sensors that all speak different technical dialects, different protocols like MQTT or CoAP.
Getting them all to talk to each other.
And to your existing legacy IT systems, that is brutally complex. Some studies show that integration effort alone can eat up 30% of the total implementation budget.
30% just to connect the dots. Wow. What about the sheer volume of data we're creating with all these sensors?
That's the second challenge, data overload and scalability. Everything we've discussed, CV, predictive maintenance, IoT, it all generates just astronomical amounts of data.
And the forecast for that is insane.
It is. It's expected to hit around 175 zettabytes globally by 2025.
A zettabyte is a trillion gigabytes.
A trillion gigabytes. Dealing with that requires immense computational resources. You need scalability, especially since those deep learning algorithms for prediction are very resource intensive.
So it's not just about storage, it's about having the processing power to keep that real-time advantage.
Exactly.
And finally, the people. Who is going to manage the zettabytes and program the robots?
That's the third and maybe the most critical hurdle, the workforce and skills gap. Technology drives efficiency, yes, but the World Economic Forum predicts 85 million jobs could be displaced or radically changed by 2025.
So you need new skills.
You need a whole new skill set. You have to bridge a skills gap in data science, AI analytics, robotics maintenance. The people who can operate and interpret these systems are in very high demand and very short supply.
So companies have to plan now to either hire or retrain for that expertise.
They have to. It has to be part of the strategy.
So the reality check is clear. These technologies offer powerful long-term transformation. You even see stats like a potential 25% cut in material waste. But getting there means strategically budgeting for high initial costs and navigating some really intense integration complexity.
That's the summary. AI is letting the digital twin become so much more than a simple model. It's turning it into a proactive, predictive engine that fundamentally improves workflows, cuts risk, and provides real, measurable financial benefits.
We noted earlier that the research is really focused on the construction and operations phases, which makes sense, right? That's where you see the most immediate cost savings.
Right.
But the early planning phase and the final demolition and recovery phase, they're less emphasized in the current studies. But the whole point of a digital twin is that its knowledge lasts the entire life cycle.
And this raises an important and, I think, provocative question for you, the listener, to explore. Given the immense pressure for sustainability and for a circular economy, how can the industry leverage all that structured data and virtual knowledge stored in the digital twin to unlock that currently overlooked phased demolition and recovery?
So using the twin's data to inform the end of life.
Exactly. How can the twins' data on material types, their exact locations, their structural history, how can that optimize material reuse and circularity? How do we turn demolition into an efficient material sourcing process for the next generation of buildings? That is where the ultimate sustainable value of the digital twin really lies.
That's it for today's episode. We hope you enjoyed exploring how digital workflows are transforming the construction industry. Don't forget to subscribe and join us next time for more insights into building smarter. Looking for more knowledge and inspiration? Head over to our website. You'll find everything you need to keep building smarter.